What's up, guys? My name is Alberto Minar, and today we're doing SRT521 Lab 7. It's about k-means clustering. In this lab, I will use k-means clustering to perform unsupervised learning. I will explore how to find the optimal number of clusters and how to identify the appropriate features, and finally how to interpret the results. Okay. And so in task 1, we will learn how k-means work. We'll have to create a Python script to do the following: dataset with 100 rows and 2 columns. It's a 2D space with the XY, and we will call the k-means algorithms from scikit-learn and calculate WC. SS1, also known as sum of squared Euclidean distance and cell-width score using Euclidean distance and cell-width score function from scikit-learn respectively. And we will show graphs, data points, and cluster centroids at scatter plot 2D. And so we will also plot the WCSS cell-width score for each k number of clusters. This program generates random data sets, applies k-means clustering, and calculates the WCSS and cell-width score, and plots the result. This program generates random data sets, k-means clustering to different values, and data points, cluster centroids, and cell-width scores. And we can customize k values lists to include desired number of clusters for evaluation. But it says that we will have to run a script on different number of clusters, 2 to 20, basically. So I will show you how I'm going to do that, respectively. So let's get this done in action. So pretty much this is the random data set that we created, right? It's 100 rows and 2 columns. And the k values, I just have to put it in a array: 2, 5, 10, 15, 20. We don't need to do 2, 4, 6, 8, 10 or 2, 3, 4, 5, 6. We just make this one 2, 5, 10, 15, 20. We can customize this by other values if you want, but this is how I do it. And as you can see, this is how it iterates those numbers above, and to calculate WCSS and cell-width score over here, and print its item in the cluster. Okay, so it's a little shortcut, but it does the work. And we also plot the data point and cluster of the centroids, right? And we will see how the centroid move from one place to another in the graph, right? And so and finally we'll have to plot the cell-width score, which is the elbow k-means, right? That's what we're going to find out. So let's run this one, guys. So our program runs, and as you can see, it starts with the cluster number 2. K is equal to 2 clusters, right? As you can see, there are 2 x's there, and it divides the dot into 2 clusters, right? And it's red and blue, and it calculates the WCSS, which is I should have showed here. We'll do it in the command. So here, yeah, it's better in the command line so that I can show you the clusters. So there are 2 clusters, start with 0, and then cluster 0, and then cluster 1. And yeah, this is the graph here. I already explained that. And so if I close that one, it's going to move to cluster is equal to 5. So you can see 5 x's over there, and it's divided to 5 colors. So it's kind of like neat coming through here. And if you see here, there are clusters 5 over there, right? As you can see. So we're here right now, guys. And we just have to close this one, and it's going to pop up the next one. Yeah, k is equal to 10. 10 x's. And then our 10 groups, you can say, or divided to 10 groups, cluster, right? And from here you can see also 10. And as you can see, the number of clusters is, there are less and less dots inside the cluster. So that's obvious. So let's move it to up to 20. So it's pretty much self-explanatory, everything. So you can see 20 clusters here, and the number of groupings among the dots is a lot smaller now, as you can see here, right? So that's how the program works. And this is the I forgot to mention about the centroid, right? As you can see, the x move to the center of each group, right? As you can see here, there are 2 x's on top here, but it's kind of like go neat over here, and then it's the more dots over here. It put 3 x's and put in the middle the centroid of its group and cluster. So the cell-width score, it looked like it's in 15, right? 15 is the sweet spot for the k-pole, right? Over here, if we put 15 k values, k-means is 15 according to the cell-width score. Moving on, we're gonna do task 2, test k-means on a given data set. So this time we will have input CSV file, and pretty much the same thing that's above, except that the input data is a data set with a CSV file. So I'll explain you what I've done over here. If you remember from the assignment 1, I have the data set that was cleaned already, and transform and normalize and binarize. So I use that data. It's the same file from Kaggle, and yeah. So I use this data set, and I use these columns, right, to use as a cluster, to cluster it and to regroup them, right, under size of initial data and the DLL characteristic. So the reason I use this, I've seen it manually, and there are big differences in terms of size of initialized data and DLL characteristic between benign and malware files, right? So let's run this, guys, and see how the program calculate WCSS and the stability score, right, and the centroids. Pretty much the same. We will have to do this thing again. Do 5, 15, 15, 5, 20. Oh, what about 5 there? Okay, let me just edit that, guys. Okay, it's edited. It's gonna try 2, 5, 10, 15, 20. That way we will do it quicker, and the cluster will cluster 2, 5, 10, 15, up to 20 cluster, right? So we'll do that again. Let's run. Oh, I have to do this in the CLI. Now, moment of truth, we'll see this happening in action. Okay, we'll do it in the CLI so that we can see further. So cluster equals 2, k equals 2. We have 2 x's there, and those are the input dots, right, for the size of initialized data and DLL characteristics. And then k is equal to 5, so there are 5 colors you can see in 5 axis too. And 10. If we group them to 10. And it's the same idea. It's the more the cluster is less and less membered dots in the picture. Okay, so according to stability score, look like this is the elbow to me, and the sweet spot for K means is 15 in this graph. So I hope you guys enjoyed this video, and thank you for watching, and have a nice day. Bye bye.